Department of Mechanical and Production Engineering in the University of Mauritius. He has done his doctorate from in the manufacturing strategy for apparel making from University of Huddersfield, UK. He has done his masters from University of Birmingham in integrated manufacturing systems, and presently he is working as a manager in the University of. He is also holding the post of manager in the University of Mauritius Training Center. He was head of the Mechanical and Production Engineering Department, and he has been awarded the Toyota Best Prize for Best Thesis from the University of Mauritius. He has done various sort of consultancy services, and his research areas includes business strategy, formulation, implementation, quality management systems, performance management and productivity appraisal systems, and his knowledge background includes design and delivery of lectures for UG and PG programs in quality engineering, business strategy, production and operations management, design of manufacturing systems. He is professionally associated with Institution of Engineering and Technology, MIT UK. He is also a corporate member in the Institution of Engineers. He is having very vast publications and in the various reputed journals, and he has also prepared various around 11 technical reports, and his some of his key professional activities includes he is a accreditation coordinator, mechanical and production engineering department. He is chairperson in the faculty administration quality assurance team. He was also a member of Senate of University of Mauritius. He is a member of faculty research. He was member of faculty research committee from 2002 to 4 and then 12 to 14. His services to the community includes he was he served as a president in the Parent Teacher Association, SIG State Secondary School from 2015 to 17. He is also a member of Lions Club. So once again, I will like to welcome Hariram sir to our program. Sir, you may. Now I hand over the mic to you.
Yeah, Professor Horiram, am I audible to you? Professor, can you hear us, Professor Dinesh? Okay, but then can I request you to just switch off and then again log in? It seems there is some problem in your microphone and speaker audio system, because earlier you could hear us. I have requested Professor Horiram to once exit and then come again. So let him come back. Till then, I will just brief the topic he is going to cover. He is going to cover the quality control and quality management in system engineering, because quality is something which is most desirable parameter and attribute, actually, we say. And that's where how it has to be in context of system engineering has to be looked upon. He will be dealt by him. Professor Horiram has been associated with various consultancy projects in and around Mauritius and even beyond. So we had been meeting quite a number of times before, and while his visits to India, and then I got an opportunity to visit Mauritius. We had academic and professional linkages. Academics, we used to get the research reports from their side, and we used to send our doctoral thesis to them. Yeah, I think now is it audible now, Professor Dinesh? Is it audible? Oh my God, no. Then it seems something wrong with your audio because maybe I have requested him to check his audio system. Maybe audio settings there's some problem, or I can see a yellow sign, low bandwidth it seems. Let him get back with a better audio system, then we'll be able to talk to him.
Hello.
Hello.
Yes,
Yes,
can you hear
you
me?
are audible. Oh, so great. Very
Great.
happy to see you, hear your voice here.
I'm really
So,
sorry about that. Yeah.
no, no, it's all right. It's all right. It happens so sometimes. So, Professor Huriram, you have been introduced by Professor Mishra to the group because you were not able to hear. So, I will just brief about the group. It's a group of 152 faculty members from all across the country, India, and they are all from technical institutions working at different levels of teaching faculty and teaching student various courses. It's an interdisciplinary course. I mean, participants are there. The whole group is interdisciplinary. We have participants from all these streams. And I will now request you to please go ahead with your topic, quality control
सर
and
उनकी साइड से
management in system engineering.
विघ्नेश सैनी सर उनकी
हाँ
साइड
जी, हाँ
से
जी.
कनेक्टिविटी इशू है.
Yeah.
हाँ, वो मैंने लिखा उनको.
Okay.
Yeah. So you can start, please. You can keep your video off. Probably that will help.
Okay. I'll just share my screen if possible. I'll just I had to reboot my computer, so I'm just looking for the presentation. Where that? It is. Okay, can you see my presentation?
Yes, sir. It is visible.
Great. So,
Yeah, it is very
thank
much
you.
visible. Yeah.
Yeah, thank you very much, everyone, for inviting me to this session. It reminds me, of 2016 when I was there at, Maulana Azad National Institute of Technology, and I had similar problems, starting my presentations in 2016. But yeah, technical problems always happen. I had to reboot my laptop, and it seems it had to do with the configuration of the WebEx. Um, Somehow my system didn't really accept it, and I had to disable one of the options to get accepted. So that's part of systems engineering, and I think you will realize when we talk of systems engineering and quality in systems engineering, it's important to look at the integration of all the aspects. Otherwise, the system doesn't simply work. So thank you very much. For those who don't know me, I'm Dinesh Hariram. I'm currently the Dean of the Faculty of Engineering at the University of Mauritius. I'm not an expert in systems engineering per se. My area of expertise is more on quality management, on business strategies. But obviously, as someone involved in engineering, in mechanical manufacturing engineering, I have been dealing with a number of issues associated to development of systems, design of systems. And when I was, invited for this session, I went into, what systems engineering is all about and how quality systems, quality control fit within the context of systems engineering. I realized that we do it all. Everyone involved in engineering. Uh, yeah. Hello. Is there any question? Yeah. For those not intervening, those not intervening, it will be good if you can, put your mic off so that, if you have questions, obviously you can, put your mic on and you can intervene anytime. I have no problem, if you want to stop me anytime during the presentation. Because it's a 1 hour roughly presentation, so we may not have a lot of time for discussion. So what I was talking about is, when I looked at, systems engineering, I realized that I think all of us engineers, if you are a practicing engineer, in one way or the other, you use this approach of systems. And because a discipline, an engineering discipline doesn't stand on its own. I think we should appreciate the interaction of various fields. If you are talking of let's say design of a dam, it's not only civil engineering. There's all the controls that go into that. You've got the mechanical work, the pumps, and so on, the piping systems and so on that go into that. If you're talking of manufacturing systems, again, you've got the mechanical systems, you've got the control systems, you've got the electronic systems, um, uh, and so on and so forth. So engineering, systems engineering allows us to appreciate this, interaction between various engineering fields in the context of achieving a goal, in the context of delivering a product, in the context of design. I think we all realize engineering is about designing, um, coming up with something that will be helpful for the community, for the business, and so on. So when we're talking of systems engineering, it allows us to have this broader perspective. Um, has it been a field in itself for many years? But I think in recent times, there's a lot of interest in systems engineering. I think this is to the credit of people who have been using the concepts in various areas. So when we talk of systems engineering, we've got the engineering aspect, but also systems engineers have this, capacity to look at everything around, the development of the system. So it's you've got the hard part of it, the hardware part of it, and then you've got the soft part of it, where we talk of whether we are meeting the requirements of the customers. If you're designing something where you have not taken on board the requirements of the customers, somehow there's a problem. So the soft part of it, the stakeholders, have we looked at the risk involved in the design? Have we looked at the constraints associated to the manufacturing of the product? Have we looked at the impact of the product when it is used on the environment? Today, we are working within the context of the sustainable development goals. Have we, made a proper assessment of the risk? Have we looked at the quality aspects, the human resource aspect, and so on? So, when we talk of systems engineering, it's not only the hardware part, it's not only the engineering aspect, but also the management aspects of things. And this is where systems engineers are very much appreciated for what they do in their designs and so on. They bring people, they bring things, they bring engineers together. So overall, we are talking of an interdisciplinary approach where we're talking of this engineering, it's more of the design of the systems. And then, you know, when we are talking of the soft aspect, we are talking of all the issues associated to the product or the service um, during its lifetime. And in fact, today we go even beyond, you know, the lifetime. What will happen with the product after its useful life? You know, how do you uh, reuse, recycle, and if you can't reuse, recycle, how do you get away with, you know, what remains of the product? And this is a very challenging topic for engineers in general. For, you know, for the benefit of probably of students who are attending in engineering, we very often refer to, you know, complex problems. And complex problems doesn't necessarily mean complicated or difficult problems. The complexity of the problem is most of the time associated to the multiple dimensions of the problem. So it's not only development of a gearing system. It's not only, you know, development of a mechanism that will move a product from one point to the other. Uh, there, the complexity is limited. But when we are talking of development of a product which will be used, you know, by the community, by the common man, and what are the dimensions in relation to the environment, to the quality, to the people, to the stakeholders. And this is where the complexity comes in, the cost aspect, the economic aspect of the product, and so on. This is where the complexity comes in, because we've got to look at all these aspects to be able to come up with the development of the product. So this is, you know, more of, you know, putting things into context. We also have, this is, if you've done, I think you've been, you know, listening to various speakers on systems engineering, and I'm sure you've seen this V diagram when where we talk about the association of, you know, each stage within the development of a system. You know, it could be a mechanical system, an electrical system, you know, an automotive system, and so on. So looking at, you know, the requirements of the customers at each stage of the development. I'm sure a lot of you have been doing, you know, engineering design, and you've got the design process where you have a number of stages that you go through before you come up with the final design. So how do you link, you know, all the stages of the development of the solution um, in relation to the requirements? So this is something which is, you know, very much used by, you know, systems engineers as a, you know, as a foundation tool to ensure that whatever they are doing it the right way. This is just, you know, a picture that I picked up from, you know, from the internet when we're talking of systemic or systems engineering. It gives you, you know, an illustration of the various components, you know, in this very simple example of a robotic arm. We can see, you know, the mechanical system in there, the control system in there, the electrical system in there. We need a foundation. So you've got the civil engineering aspect, and so on and so forth. So systems engineering, to put it, you know, very simple, bring all these aspects together. So just like I mentioned, you know, system design could be very specific to a specific discipline, mechanical, electrical, and so on. But it could be, and in most cases, when you look at systems, uh, we look at a combination of these fields. And, quite often, if you are involved in project management, for instance, you constitute teams where you can put all these competences together to be able to come up with to deliver in line with the objectives of the project. Could be anything, construction of a building involves, the mechanical, the electrical, the chemical, and so on and so forth. So that's the core of system engineering, and then you have the soft side, which I mentioned earlier on, where we talk of systems management. In delivering a particular project, it's fundamental that we also consider the systems management tools. Uh, and in there, you've got a whole range of things that engineers have to deal with. If you have a team, you've got to manage the team, so you need to have some competences on human resource development, human resource management. You're dealing with customers, stakeholders, and so on. You've got to take on board the requirements, the changing requirements of the customers, stakeholders. Today we are faced with a very dynamic, external environment. So we've got to take on board what is happening and what are the new tools and techniques and so on which are available. We may have to consider norms and standards while we are doing outsourcing, purchasing, and so on. Risk assessment is an integral part of whatever we do. And then you have obviously the topic of the day, which is, quality. When we're talking of systems design or systems engineering, quality is an integral part of systems development. So if our design, we always, in the good old days, you would design, you would manufacture and employ a number of people to check for quality, and this is where we talk about quality controls. So they have a number of parameters that they have to check within a production line or whatever it is. And they compile the data, they plot it in check sheets and so on. That's quality control, and we quite often act based on the results of the data that we have collected. Um, we have evolved a lot from quality control today. We are living in a world of total quality management. Though not every company has reached that level of sophistication in terms of quality, in terms of putting a quality culture within the organization, but I think all businesses are very much concerned to be able to put in place the appropriate quality system, whether it is an educational institution, whether it is a health institution, whether it is a manufacturing organization, whether it is a project management firm. Quality is a sine qua non condition. And we are not talking of quality control here. We are talking of having a quality culture where each and every person takes responsibility, is accountable, for the work that they deliver. I think the day when each and every person within an organization becomes accountable, takes responsibility, of the outcome, of the task that they are delivering on, we would have reached, a stage of uh, having a quality culture within the organization. Um, that is obviously driven by a number of, factors. You need to have a number of factors which will allow you to reach that level. And we'll probably look at a few of these as we move along. Um, to start with, I think it's good to talk about what is quality. I think everyone knows about, what is quality, but it's always important. There are a number of gurus that have come up with the definitions of quality and so on, but it's always important for you, for each one of us, to be able to work out a definition for ourselves in terms of what we do, what quality means to us in the function that we are, delivering. Today, we've got, you know, mostly academia, I understand, people from various institutions. We've got students who are also here. Um, Probably you have to do some thinking about if you had to write a definition of quality for the work that you're doing, what would that definition be? I've been trying this exercise for many years now with my postgraduate students. You would probably argue that this is a very easy thing to do. It's not. It's once you put you know just to take an example, if you're going to a retail shop, or to buy a jacket, or a pair of shoes and so on, what quality means to you would not be the same definition as for your friend. You could have a very close friend going to purchase of a same product, but you would argue that this is good quality to me, and your friend may argue that this is not good quality. So the definition of quality varies from person to person, and this is what makes it challenging to systems engineers. This is what makes it challenging to manufacturing companies, for instance. If you had, as a manufacturing company, to meet the requirements of customers, you should be able to make an analysis of what these requirements are. Now, if this requirement is varies from person to person, then you end up in trouble. So what I mean is, when you look at quality, there is a definition which you can pick up one definition which cut across customer satisfaction. You would argue that it goes across all people. Everyone wants to be satisfied, but it's not enough for an organization involved in the development of engineering solutions. So when we're talking of customer satisfaction, for instance, or meeting customer expectations, you as an engineer, you should know, you should be able to put some figures in there. What are these expectations? And this is what allows us to develop our product design specifications. Once you have the data, the figures in terms of what is the color that people are looking at, what is the size that people are, what type of material that people are looking at, what type of weight that people are looking at, control system, the user interface, and so on. You need to have an idea of the expectations, and you develop your product in line with those expectations. Then you would say that, okay, we are meeting the expectations. But it's not an easy business, quite simply because expectations themselves have no limit. We always talk of, the sky is the limit in terms of expectations. So, but for engineers, you've got to be realistic. Your objective has to be, smart, specific, measurable, achievable, realistic, time bound, and so on. So, when we're talking of quality, the starting point to me is to uh, write down, to agree on what it is that we want to achieve in terms of quality. This is the starting point, because your product design specification will follow that definition. Um, uh, Yes, this is just to extrapolate a little bit in terms of quality definition. I think there is yeah, I'll come back to probably the main considerations in quality. What is good quality? Uh, what are the benefits, if you want, of good quality? I think everyone would know that there's no debate about it. It leads to more business. This is for even for engineers. But if you are involved in business, what is the bottom line for you is profit, right? But engineers have other considerations: the health and safety, the impact on the environment, like I mentioned earlier on, the performance of the product, and so on, are key considerations for engineers. We shouldn't forget that uh, quality. It used to be, this is a very good quality product. It used to be a differentiator when we are competing in a particular market. It's no more. You do have differentiation factors which are used as a means to compete, but quality is an integral part um, of a product design. So in systems engineering, whichever system we are talking about, is it a development of a software? Is it development of a mechanical system, of a a motor, driving, generating energy, um, hydroelectric power system, and so on. Whichever system we are talking about, we've got to start with, the uh, the assumption that we're going to have a product whereby quality is inbuilt within the system. These are some of the characteristics, if you want, if you're talking of a product, the issues that quite often engineers look at. So the performance of the product, and I think as engineers, you're fully aware, different performance parameters with different products. So you can, put some figures in there. What are the performance parameters? What are the specifications? And so on and so forth. Likewise, you've got, when we're talking of, systems, it's not necessary that we are only looking at manufacturing systems. It's not necessary that we are only looking at, production systems and so on. We could be talking of systems engineering within the context of a service environment. And this is, it's quite common today, to apply the systems engineering concept within, even a service environment, whether it is a bank, whether it is a you know a health department, within the education sector, and so on and so forth. So even if you are dealing with systems approach within the service department, there are a number of factors that guide systems engineers around the development of their system. I think we mentioned about this when we're talking of quality. You've got the customer point of view, um, but you have a number of people involved within the the process of development of a product or the process of development of a service. You've got a number of stakeholders. Uh, so quite often, there are, or if you want, the understanding um, of quality across the value chain may not be the same, and the objective may not be the same. But it's important to have a shared you know definition of quality, so that everyone is working towards that definition, everyone is working towards that goal. We mentioned about the customer point of view. You've got the manufacturer point of view. You've got within the organization the process point of view. The process engineer will have his own definition of quality. The product engineer will have their own definition of quality. The marketing people, the merchandising people, you may have a definition in relation to the cost and so on. So different people may have different views of quality. I think this is where the debate most of the time is. Once we agree on the objective, the long-term objective in relation to quality of the product or the system that we are developing, it's then everything takes its shape and goes into place. There are a number of tools that have been developed in relation to achieving quality. I'm going to probably go through very quickly because of the time constraint, very quickly on some of them. We cannot really talk about quality without mentioning the names of our gurus. Uh, the teachings of Edward Deming, Juran, Feigenbaum, Taguchi, Shingo, Ishikawa, and so on, are fundamental. There is a lot of common understanding between the various gurus of quality. Um, but I think what is important, if you are to implement a quality system within an organization, or if a systems engineer has to look at how do we integrate quality within our system, then probably we can consider the tools that have been put forward by the various gurus. I'm going to probably talk about a few of them, which has been included in the presentation here. But before going to that, it's important to probably this is something that I picked up from ISO 9001 2015 on the on the vocabulary associated to the ISO standard, which talks about what is quality, what is a system, what is a quality management system. And there have been, a number of quality management systems that, are in place today. Before you go into a quality management system, it's important to have, a the foundation has to be good. If you want to put a quality management system within an organization, within a team, the foundation has to be good. And when we talk of the foundation, we quite often refer to the principles of quality. You need to have a driver, you need to have a leader, you need to bear in mind, all the time, what are the needs of the customers. And these needs, we should all realize that it keeps changing at times on a daily basis. We've got to look at whether we've got the right people, and whether these people are motivated enough in the development, in the design of our product. Do we have a motivated team? How engaged they are? And if they are not, what do we do about it? We've got to look at, do we have the right processes? Do we have the right equipment to be able to deliver in line with the customer requirements? Do we have the competences? Do we have mechanisms to look at shortcomings? We will always have shortcomings. If you look at the V diagram, you will see that, you start with an idea, and then you develop, come up with a design, you test it. It doesn't work, then you have to, improve on that again, test it again until you reach the final product, and so on. So these are basic principles organizations need to have in place to be able to construct the quality management system. This is also very much common in the ISO standard. Uh, the In terms of quality management systems and techniques, I think we all know about uh, uh, use of quality circle, use of total quality management system, Six Sigma, Lean, Gemba, Kaizen, uh, just-in-time techniques, and so on. So I'm not going to dwell too much on that. What is a quality circle, and so on. On TQM, I think this one is quite complete in terms of the tools and techniques and so on, because when we are referring to quality, we talked about quality control earlier on. From quality control, you've got quality assurance, then you have quality management, you've got total quality management, and SPC and so on form part of this new breed of engineers implementing quality systems. So this slide, if you want, is very useful to look at the tools and techniques that are available for managing quality. Then you have Six Sigma, which is a topic in itself, whereby we look at a mechanism for continual improvement. Lean is about waste reduction in our systems. Kaizen or Gemba Kaizen is all the tools and techniques that are used for reduction of waste, reduction of defects, improving productivity within organizations. So these are more or less, if you want, management techniques. Uh, each of these techniques, I haven't listed all of them here, but each of these techniques have a number of tools associated with them. And I think it's important as a systems engineer to understand which tool is relevant for me, and how can we use it in the process of systems engineering. So what I've done, I've got probably 3 or 4 slides on the most relevant tools to me. But also, we can't go through all of them. There are hundreds of tools available around. I would always start when we're talking of systems engineering. I would always start with the house of quality, or those involved in design quite often refer to it as the quality function deployment matrix. The good thing about this matrix, even if it's quite cumbersome and at times challenging to work out, the objective measures, which are, the figures that you will need for the development eventually of the product, but it allows you to look at, to match the requirements with, the engineering characteristics. Matching the requirements with engineering characteristics is looking at what are the needs and how can we achieve those requirements, those needs. How can we do that? And this is where, at the top of the house of quality, you've got the relationship between the various ways we can do that. So it could be, it concerns the materials, it concerns the structure, it concerns the control systems, it concerns, the fluid movement of the fluid, it concerns the user interface, and so on and so forth. So the engineering characteristics allows us to have a very broad view of who are the people, who are the engineers, who are, the competences, or what are the competences that are required for us to be able to, to deliver, the product or the system that we are talking about over here. The house of quality also allows us to compare what we intend to develop as a system with existing systems. And this is also very useful for engineers. We can't, lay a blind, eye on what is existing already. Whatever we do has to be better, has to be competitive, has to have differentiated features so that you can sell it. If you're developing a system which nobody wants, there is no point doing it all together. So I would probably start with this as a tool. This is just to illustrate, of course, if you want to go into house of quality, the development of house of quality, how do you get the customer requirements? How do you get the engineering characteristics? How do you do the competitive assessment? How do you do the targets? And how do you set up targets yourself for the new system? Is a topic in itself, and we can spend hours just doing house of quality. The second tool that I would like to probably present to you is IDEF, which is Integrated Computer Aided Manufacturing definition, which is, as the name says, it's more associated to software development, data management systems. Those involved in developing of software architectures, and also automation of processes within organizations, service or manufacturing, and so on. Let's say you want to develop an ERP system, which is an enterprise resource planning system. You need to understand, how data flows within the organization, how material flows within the organization, how decisions are made, who makes the decisions, what are the policies, what are the procedures, and so on and so forth. Now, if you want to model that, I think this one is one of the best tools I could see for the modeling of, of systems for the purpose of analysis, because we are not creating or developing a system, just to illustrate, how things are. Usually, you develop this system, the as is model. You analyze it, you question what is happening, and then you develop your to be model based on, the objective function. What it is that you want to automate, for instance, and how you're going to eliminate, a number of, probably uh, processes in order to improve productivity, efficiency, and so on. So the way it works, this one is we look at all the inputs which come to the left. On the right hand side, you will have all the output leaving the process. So it uses a process approach. So you will see the processes in there, and the linking of the processes between, you can start at very high level using a black box to represent an organization. Look at all the inputs coming into the organization, all the output going out of the organization, the products, the services, and so on. All the controls that are used, that would be on the top. The controls would be all the policies, all the procedures, all the documents that are used as a control to convert the input into an output. Um, uh, for instance, if you're a lecturer, you've got to deliver a lecture. There are certain controls. You are bound by, the ethics. You're bound by, the quality policies of your own organization. You're bound by a time to deliver your lecture, and so on and so on. So you've got controls. And then you've got, for a process, you've got mechanism, which is the human resources and the tools and the equipment that is used. So it uses the icons, input, control, mechanism, output, and mechanisms, and it links all the processes together. For systems engineers, in addition to the QFD, the House of Quality, I think this one is probably one of the tools which is very much used uh, for the purpose of, implementing changes within organizations and so on. The next tool I would like to share with you is, system dynamics. It's again a very macro view of what is happening, but you can uh, go into details. There's nothing that stops you to go into the details. For instance, the IDEF, you start at the very top level and you can go into the details. And there are software. You don't need to do that, all of this manually. This was developed in Visio Professional. There are softwares which allow you to develop your QFD, to develop your process model, your process map, to develop, system dynamic software are available. Here we look at, it could be problem oriented. You've got a problem and you want to find the solution and the impact, of the solution on, everything that goes around, the problem. Here we are looking at a very simple example of an equipment producing, defects. So what are the impact and what can be done? What could be the solution, what are the tools, and so on. So you can, I mean, systems engineers, when you're doing systems engineering, bringing things together, if you want to have a holistic approach, this is, a very good tool for use. The other one is, I think this one probably everyone who's done mechanical or even, quality engineering programs are aware of, risk assessment. And for systems engineer, um, it's it's fundamental to look at what are the risk, um, of something going wrong, especially at when you're working at, the development, the design, the engineering stage. It's important to make an analysis of the probability of the risk and what would be the impact. If there is a high probability and the impact on, the impact could be anything. It could be in relation to the cost. It could be in relation to the process. It could be in relation to the environment and so on. It's up to the engineers to define or to customize this matrix for their own, purpose. This is just an example. So it allows systems engineers uh, to take appropriate measures uh, to mitigate risk. And nobody wants, their systems to fail. So, in ISO, for instance, today, we no more have, preventive measures or preventive actions. Um, in the standard, the word corrective action is still there. The word preventive action has simply been replaced by risk assessment. So this is how important, risk is, and the emphasis being placed today by, engineers in general, not only systems engineers, but engineers in general, in relation to risk. Um, it's also linked to health and safety and so on. Could be a risk assessment could be undertaken in terms of the health and safety and so on. So we've looked at quality function deployment, the house of quality, IDF0, system dynamics. There is another one which is quite often used for the purpose of, more for the purpose of uh, analyzing failures. What can be responsible for a failure? In the design of a system, a lot of things can happen, can go wrong, and uh, at times it becomes very difficult to be able to identify the cause of failures and so on. So it can be used as a simulated model, if you don't want to, test case your design after production, but it can be used as part of a production process. It's the Taguchi method, the design of experiments, which allows you to look at uh, each of the contributing factors, which can lead to a failure, and how you produce your the the matrix to be able to make an analysis of uh, the root cause of failures and so on. So this is another tool that is quite often used. Um, this is probably my last slide before we open probably the floor to some discussions. Um, you have, when we talk of quality control and so on, you've got the conventional, if you want, tools, which have been, in use as part of quality control, as part of quality assurance systems, as part of statistical process control, and so on. And uh, you know, I didn't want to go into these because uh, these can be used as part of any total quality management or any quality management system. So you've got the fishbone diagram, or the cause and effect diagram developed by Ishikawa, check sheets, control charts, which have been there for probably a century now, probably more. Use of Pareto. The Pareto principle uh, is something that comes up all the time. We call them the vital few. What are the vital few? Priority areas for us, and so on. Scatter diagram, which allows us to look at trends in the collection of data. And then you can have stratification, where we are looking at different categories of data, and so on. And you can use stratification together with scatter diagram, with control charts, with histograms, and so on and so forth. I think that's about it. I tried, within an hour. We cannot. We either have a broad idea of what is systems engineering, and how quality management systems and quality tools fit within the context of systems engineering. For those are not too much conversant with quality systems and so on, I suppose now you have an idea of what is quality, what is quality management systems, and what are probably some of the tools that fit within the context of systems engineering. I repeat, systems engineering is not one field of engineering. It's not mechanical, it's not electrical, it's a bit of everything. So it's probably a little more challenging to systems engineers while making analysis of of the system uh, than mechanical engineer or an electrical engineer, who is more or less focused into their own structure, or their own product, or their own design, which quite often is limited to the field. Um, so I hope now we could not, within the time frame that was allocated, we cannot, go into the details. But just to give you an example, if I have to talk about IDF modeling, I can spend, 2-3 hours just on, how to develop the system and how it is used, and so on. Likewise, for system dynamics, for risk assessment, for design of experiments, we probably, for those who have done design of experiments, will probably take 6 hours or 9 hours to go through that. Tools of quality, takes whatever time it takes. So this was more of an introduction to the subject. I understand there are people from various domains, various sectors, and also students who are present for this session today. Let me just finish by thanking again Dr. Soni and all his team for giving me this opportunity for intervening in your program. I think this is a very good thing that you're doing, and you should be commended for the initiative. And if there are questions, I would like to take them before we close the session. Thank you very much.
Yeah, thank you, Professor Dinesh. In fact, we are grateful to you for you have taken time out of the condition you were narrating in the beginning that it's because of pandemic, the university is closed. Sometimes we take the problem as an opportunity. So when we are sitting home, even we are sitting at home at NIT Bhopal, the boys are not there, the students are not there. We get more time to focus on our work. So but we understand the situation. If any questions are there from the participants, as Professor has said, he would be able to take few questions because we have still 4 minutes time to conclude the session. So any queries? Professor Dinesh, I would like to request you to kindly share with me the presentation if there is no issue in that, because the participants are asking for the presentation. So
I'll send you by mail.
okay, thank you very much. Thank you. So if no question, then I think we'll call it a session. Before that, on behalf of Maulana Azad National Institute of Technology, Department of Mechanical Engineering, the whole group, and of course my colleague Professor Mishra, who has gone out for some meeting and he is not there right now in the meeting. Thank you very much, Professor Dinesh. We'll keep in touch as we have been doing before. It was a long gap. After 4 or 5 years, we
Oh, yeah.
interacted. Yeah. So thank you very
Thanks.
much.
Thanks a lot.
Yeah.
Namaskar, and
Namaskar.
my regards to the whole family there.
Yeah.
Cheers.
Thank you.
Thank
Thank you.
you.
Same to you. Thank you.
Bye.
Before we go for the next class, somebody asked, yeah, we are going to share all the presentations, but it will take a day time to compile because all the experts are in rush. So some of the experts have sent, some of the experts will be sending me. As soon as I receive all the presentations, I'll make a folder and zip folder will be sent to you on mail. Don't expect this on WhatsApp group. I'll send it on mail. So there is a mail group where we are passing on every information. The same group, this folders will come. A zip folder will come. Then after this, we can call it a session, and I'm switching off if no other matter. As a coordinator, whenever we find time, we used to discuss. So if you have anything to discuss, you can we can do it now.
Sir, what about the content of or nature of the test that will be conducted tomorrow at 5 o'clock?
Okay. I do understand. That is because we all are professors and we know the you know seriousness of any examination. So
Right,
one thing I will tell you that the whole is in the form of quiz. So
okay,
the quiz, there will be 30 questions. Every question will have 4 objectives. So the way you are checking the boxes in your feedback form, the same way the
right,
quiz Google form will be circulated at the prescribed time or little behind, little ahead. That will depend on the tomorrow's proceeding.
right,
And
sir.
you will be given 20 minutes time to complete it. So 30 questions in 20 minutes time. What I can
Right,
assure you that if you have attended properly and if you have gone through the discussion held during the meeting, even otherwise also, they are very basic in nature. So we don't want to test your knowledge. I know we
right,
are
sir.
all faculty members and we are all from different heterogeneous backgrounds. So we keeping in that mind, we wish that there won't be any trouble to attempt that question paper. It will
Thank you,
be an
sir.
objective type question paper, 30 questions to be solved in 20 minutes and will be in the form of Google form. And that will be self-scoring. So when you submit your paper, you will come to know your score.
Right, sir. Thank you so much, sir. Thank you so much.
Yeah. So nothing to worry. And tomorrow we are going to have the first session, second session. And after that, I'm just talking to AICT people and my own director and the other authority. Normally, nobody believes in formal validatory function because what happens, 5 days program and instead would like to use that time for half an hour session, maybe something left that I can discuss. So we'll discuss and tomorrow we'll decide and let you know if any validity is there, because online function doesn't make much sense except the dignitaries have to be troubled to come and join and then speech for say 5 minutes, 10 minutes. That's what is normally. If it is there, we'll do. Otherwise, I would love to have another half a session on some subject, and then we'll call it a program. Okay, that I will let you know in the morning. Don't worry.
Right, sir. Thank you, sir. Thank you so much.
Okay, so we can now close this meeting and kindly join the third session in a say 5 minutes time.